Hi everyone, so my name is Erik Grinaker. You may know me from Siemens Talk. I'm the backend engineer here at Sanity, or one of the backend engineers. And today I'll be talking about GDPR, transaction logs, and the history API. I'm sure most of you are pretty sick and tired of hearing about the GDPR, so I'm not going to dwell too much on it, but I'm just going to go through a few of the main points that are relevant for the rest of the talk. So a quick summary of the GDPR. It's a new EU personal data protection law that went into effect this May. It basically boils down to these main points here, that you're supposed to collect, keep, and share as little data as possible, and keep it for as short as possible. You should explain clearly and fully what the data is used for, and ask for consent if necessary. You should allow the subject to retrieve, to correct, and to permanently delete their data. And you obviously have to secure the data and notify the subject and authorities in the case of any data breaches or leaks. And this is really just totally reasonable. We're big fans of the GDPR here at Sanity, and we think the EU did a really good job in deciding this law. The GDPR also has this concept of controllers and processors. So controllers are the entities that are legally responsible for the data. And processors are companies that process the data on behalf of the customer. So in the case of Sanity, we are the controller for some of our data. We're the controller for our user database and for our email subscriptions. But our customers are ultimately controllers for the data stored in the Sanity API. And so we're a processor on behalf of the customer for the data stored in our API. But we obviously have to provide tools and terms that allow our customers to be GDPR compliant. So I'm happy to say that Sanity is fully GDPR compliant. We spent quite a lot of time this spring making sure we process all data in accordance with the law. You can find some details about this in our terms of service, our privacy policy, and our security and compliance page on our website. And we also provide facilities that allow our customers to remain GDPR compliant. That's mainly our APIs for retrieval and deletion through the Grok query language and through the mutation APIs. We also have really tight security on our operations platform. All of our data is stored in the EU, which makes it really simple, and so on. But the biggest challenge we had in becoming GDPR compliant was the Sanity transaction log. So every change that's ever made to a document in Sanity is stored in what we call the transaction log. And this is really useful because you can look at the history of a document, you can look at different versions of a document, we can implement undo and undelete functionality, audit trails, stuff like that. None of this is actually user-facing yet. This is just infrastructure, but we're planning on making user-facing features for this later. The problem with this is that it's totally not GDPR compliant, because we obviously record every change to the data ever made. And the GDPR specifically says that personal data should be kept as short as possible, and it must be possible to permanently delete it. So the solution we came up with, this is an example of our transaction log, so you can see what it looks like. Every time you submit a mutation to the API, like in this example, we submit a patch mutation for the country Germany, where we set the capital field to Berlin. That mutation is processed by our API, and we update the document by setting the capital field to Berlin, as you can see. But at the same time as we're updating the document, we also write a record of that mutation to the transaction log that you see on the bottom there. And that forms the complete history of that document. So you can see in transaction 1 there was the original create patch that just set the name of the country to Germany. And then the second transaction updates the founded field and sets it to 1871. And then finally, you get the latest mutation that was submitted that set the capital to Berlin. So the question is, what can we do to make this GDPR compliant? Because we obviously can't have this full record. And what we did is, first of all, to implement limited history retention that's determined by the project's plan. So for example, if you're on, let's say, the medium plan, you maybe have 3 months of retention. And then we'll just throw away all of the older changes to the documents. And this makes it GDPR compliant because if someone asks you to delete their data, you don't have to do it immediately. You can just say it has to be removed within a certain time frame. So 30 days or 90 days or whatever would be acceptable. We'll also offer a configuration of this so that if you think 30 days or 90 days or whatever is too long, you can set it yourself to 5 days or whatever you feel is appropriate. We'll also offer custom retention rules per document type. So you can say maybe some documents you want to keep as much history as possible for, and other documents you'd prefer to not have any history at all. But this will be a paid feature that we're implementing soon. We also have a purge mutation. This allows you to delete, to immediately delete a document and also purge all history for that document in case someone stores any sensitive data or something I just really need to just get rid of as soon as possible. So the way we implemented this is through our infrastructure we call the transaction log squashing. And it basically works by, first we calculate the retention cutoffs of all the types of documents you have in your database. Then we actually replay the transaction log and we start rebuilding the documents as they were from the beginning up to the retention cutoff where we want to delete the history from. And then at that point, we introduce a create squash mutation, which has the contents at that time, at the retention cutoff time. And then we can just delete all of the previous mutations. So if you have some data that was replaced way, way back in the past, after that data has been squashed, the data will no longer exist in the history. So we can see an example of this here. This is the same transaction log as earlier. So you can see the capital mutation on the top. And we also have the, if you look at transaction 1, that's the original creation of the document. And then we set the founded field in transaction 2. And in transaction 3, we set the capital field. So let's say we want to have the history cutoff between transactions 2 and 3. What we can do is we can replay this log and regenerate the document. So we start on transaction 1 and 2 and add the founded field, which gives us the document at the bottom there, which does not have the capital field set because that's a later transaction after the cutoff. And then once we do that, we replace transaction 2 with this create squash mutation, which has the document contents at that time. And we also add some metadata, such as the authors of the mutations that we just removed, the revisions that were removed, and the original creation information. And so this allows us to get rid of like a lot of historical data that we probably shouldn't be keeping. But it turns out that this infrastructure is also really useful for something else. It's pretty much exactly the infrastructure we need to create a history API, which is something we've been wanting to build for a really long time. And a history API would allow us to look at the history of documents and retrieve old versions, look at diffs between different versions and stuff. So because the translog squasher replays the transaction log and builds the documents in order to create that the document state at the cutoff, we can also use that to just rebuild the documents in the history API. And we already designed a draft of this API, and implementing it should be really straightforward. It's just a matter of priorities. So hopefully it won't be too long before we get this. But even though we have the API, we're still going to need a studio user interface to be really useful, because end users obviously can't do anything with an API. They need a UI to be able to browse the history, to be able to retrieve old versions and so on. So that's something we're going to have to build afterwards. So we can have a look at a few of the basic features of this history API. The obvious thing is just to be able to fetch a document as it was at a given time in the past. So in this example here, we ask for the Germany document at revision 2. And so we just get that document back, which, as you can see, does not have the capital field, which comes later. We'll also be applying access control to the history. The way we're planning to do this is by using the access control rules we already have in Sanity. And we'll just apply those to the last known revision of a document. The idea here being that if you have access to a document now, you would expect to also have access to the history. The only exception is anonymous users or users without a token, because they obviously shouldn't have access to internal history for documents. Something that's a little bit more useful is getting document differences, which allows us to look at the differences between two versions of a document. In the API, we're considering returning a textual diff of the JSON representation, either as the new unified diff or maybe as Google diff match patch. And we'll possibly also add so-called blame metadata, which shows what user edited what fields and at what time they actually made those changes. So you can see an example of this at the bottom here, where we're showing the differences between the first and the third revisions of the Germany document. Highlighted in green are the two fields that were added between the first and the third revisions, while the three fields on top, they weren't changed during those revisions. So Those are as they originally were. And on the left-hand side there, you can see the so-called blame view, which shows which user was responsible for actually originally introducing that field and the time it happened. So you can see that Alice was the one that originally added the 3 fields on the top. And then on May 3rd, Alice added the founded field, and then Bob on May 7th added the capital field. And then finally, and probably the most useful feature, is a document timeline, which allows you to fetch a complete timeline of what happened to a document over its lifetime. But because there's a lot of mutations going into our documents, because people are editing and like constantly adding changes to documents, we'll probably group these transactions into sessions with a configurable resolution. That means that instead of getting like 1 million transactions, you're just going to get first a session where Alice at 9 o'clock worked for 8 minutes and made, say, 23 edits. And then later on, Bob at 11:30 worked for 3 minutes and made 7 edits. And then Alice and Bob later collaborated for 21 minutes and made 85 edits. And this timeline will also optionally include the document contents and the document diffs after each session. So you can see not only that they actually were working, but you can also see what they were doing. And those are the main features that we're planning for the History API, and we think that's gonna be a really powerful tools for editors once we get a UI on top of it. Unfortunately, there's also some limitations in this API. The biggest one that's probably going to disappoint a lot of people is that it's not possible to query a past version of the dataset using Grok. The reason for that is just that it's going to be really resource intensive. Our options are either to rebuild all the documents in the dataset, which is just going to be way too slow and use way too much memory, or we could index all revisions of all documents, but that's going to take a whole lot of space. So we might be able to implement something like this someday, but it's not something we're planning on doing for this first version. Another limitation is that we don't have an API for undeleting or reverting documents. And this is really just because it's trivial to do this in the client. You just fetch an old version of a document and just write that version however you want it. And we feel like doing it in the client just offers developers much more flexibility as to how they want to do these things, rather than us enforcing a certain way to do it on the server side. So that's pretty much it. In summary, we at Sanity are really fond of the GDPR, and I hope you guys are as well. Any document change that you make via our API is stored in a transaction log, and we can use this to build a history of all the changes. We also have limited history retention in case you don't really want to keep that history for too long. And as a sort of a happy coincidence, this also gave us the infrastructure we needed to build a history API, which is coming soon, and then hopefully a Studio UI sometime later.